Okay, well, I got a pretty cool talk in store for you guys. At least I think so, because one of the tools that I'm going to be really showcasing this evening is one that I think is probably one of the most just game-changing tools to hit IR in a very long time. And the crazy fact about it is it's free and open source. So those two things together are a couple of my favorite things. So as the talk title implies, my talk here this evening is going to be based on performing a live incident response using Velociraptor. So I'm going to ask you to bear with me this evening because most talks, right, are very slide heavy. I've got 8 slides for you all tonight because the majority of this talk is going to be live demo, the whole thing. So if you've ever had to say a prayer to the demo gods, send one up for me, because the experience says the more live demos you have in a talk, the more margin of error or room for something to go wrong. Well, you know, may the force be with me. Okay, so a little bit about me. My name is Eric Capuano. I am the instructor of Forensics 508, which also happens to take place in this room this week. But I'm a few other things as well. I'm the CTO and one of the co-founders of a cybersecurity company out of Austin, Texas called Recon InfoSec. And we do a lot of awesome things at Recon. Our primary focus is managed detection and response. So we are a SOC as a service for many companies around the country. But we're also very, very sharp practitioners in the space of digital forensics, incident response, detection engineering, SIEM engineering, SOAR. I'm really proud of the team that I've built down there in Austin. Some of the smartest and brightest people I've ever worked with. I mentioned that I'm also a SANS instructor for digital forensics and incident response. Previous experience, not so long ago actually, I was a cyber warfare operator for the Texas Air National Guard. Yeah, thanks. Got a couple of my Air Force colleagues and Space Force friends here. Also, before standing up my company Recon, I was the SOC manager for the Texas Department of Public Safety, which is a really awesome experience for me because one of the things that I had to learn in that role was I had to learn to defend a literally mission-critical network for the state of Texas on a shoestring budget. And that taught me a lot about getting as much value as I can out of open source security tools. So I learned how to wield Elk Stack. I learned how to wield OS Query, Sysmon, ElastAlert. You know, I would have loved to have a tool like Velociraptor back then, but I did not. So I was making do with all the tools that I had. OSSec, Wazoo, right? I mean, Snort, Suricata. I mean, the list goes on. I became such a huge fan of open source tools that I decided to build one of the largest blue team CTFs that still exists to this day, known as OpenSOC. I don't have that on the slide, and that's actually quite a shame. But I do have the DEF CON logo there because that's where we run it each year. And it's a really awesome blue team CTF that we put on. But at the heart of OpenSOC, it's essentially a full simulated environment with all the things you'd expect to see in a real enterprise network. Workstations, servers, firewalls, Exchange, DCs, all that good stuff. And then what we do is we run attacks against this environment in real time, and we give the participants the live response capability. Here's your Elk Stack. Here's Archemy, which is a full packet capture, open source solution. Here's OS Query. Here's Velociraptor. And we let them hunt, showing them how awesome these open source tools are, right? You don't have to have bottomless pockets in order to be good at security, right? So one of the cool things I love about the OpenSOC project is we're like the marketing team for these open source projects that don't have marketing budgets. And that's kind of what I'm liking to do today with Velociraptor. Another cool thing about the OpenSOC range is that we run a formal training component of it for private sector organizations that are looking for that same style of training. We call it Network Defense Range. It's a service that my company runs. And as luck would have it, the environment I'll be using this evening, the live environment for running this IR, happens to take place inside of that Network Defense Range. And also, really proud to say I'm also a Black Hat trainer. So I run this same training I do for private organizations through my company. I run it Black Hat each year. We'll be there actually in just a couple of months. So if you're out there, come say hello. Okay, so the agenda for this talk, I don't even really want to call it a talk because it's going to be very much a live down in the weeds demo. But what we're going to do is I'm going to first give you a really quick introduction of what Velociraptor is for those of you that are unfamiliar. And I mean quick because honestly, you're about to see it live for the next hour. So I'll give you a quick explanation of what it is. And then what we're going to do is we're going to dive right into a no-kidding APT-style intrusion, okay? So I've got a full Windows environment here, just like you would walk into any customer environment if you're a consultant, you know, something like 60, 70 systems, and I hate to tell you, but they have been ripped wide open by a pretty sophisticated threat actor. So some of the things we're going to do with Velociraptor, we're going to hunt for initial access. Let's find out, did the adversary get a foothold in this environment? Obviously, they probably did, so we're going to then look for malware in this environment through some really cool hunting techniques we have in Velociraptor. Then, obviously, I've got to find persistence, right? Because if I ever hope to eradicate this threat actor from the environment, I've got to make sure I don't let them leave any footholds behind that's going to bring them back once I think I'm done, right? Once I think I've eradicated them. So we'll hunt for persistence. And then ultimately, we're going to perform a full scoping of the intrusion using everything that we learned along the way, where the malware is, where the persistence is, where their C2 beacons might be in this environment. And I'm going to use that to kind of perform a quick scoping. How many systems in this network are hit by this, so that I could possibly hope to perform containment of this breach. Now, let me just say for my IR forensics folks, we're not going to get deep into forensics in this because it could take us days to do forensics on an intrusion like this. But what we're going to do is a really rapid IR to get from 0 to 60 on how can I at least stop the bleeding, contain the threat, and at least start the forensics process from that point on, okay? So bear with me. We're going to be moving quick here. All right, so really quick briefing about Velociraptor at a high level. So as I mentioned to you, Velociraptor is an open source project. It was built by a guy named Mike Cohen. Is almost too good for his own, or too smart for his own good. It is such an incredible tool because, one, it is extremely simple to deploy. And let me just reiterate how simple it is. You could pull down a single executable from GitHub, use it to deploy your server. That same executable, you would push out to all your clients. Boom, you now have a Velociraptor deployment. There's no complicated apt get install, various packages, et cetera, et cetera, et cetera. That's it. I could walk into a customer environment, even if they were completely air-gapped, with a single executable and stand up my server and then deploy that same executable to all of their endpoints and have a Velociraptor server up and running that's going to basically give me a blue team C2 shell on every one of these endpoints that I could use to rapidly interrogate, look for threats, contain, remediate, you name it. So incredible stuff. Now, one thing that I'll say about Velociraptor, so it's been around for several years now. I've been following it since its infancy, and it's matured quite a bit since it first hit the open source sort of area. And in that journey, I will go ahead and just disclose that Velociraptor was kind of swooped up by Rapid7. So you may see that that now it's there's a lot of Rapid7 sort of branding around it and stuff. But you know what? That's kind of a good thing in my opinion because now you know this thing has a home, right? It's got a place to stay. Rapid7 started pouring a lot of resources into it, and that's why I think it's really continued to just boom and blow up with popularity. So that's enough about Velociraptor because you're about to see plenty of it in real time. So let me give you a quick overview of this environment that we're about to be performing an incident response. This is a pretty detailed diagram of this environment. So you've got all the trimmings that you would expect in most networks, right? So for instance, I've got my server subnet over here with a few different domain controllers, exchange servers, file servers, all that good stuff. I've got several subnets down here of user land, right? So I've got an engineering department, sales department, accounting, IT. I've even got a DMZ out here with some web servers and things of that nature. Traffic is flowing, emails are moving. This is a real, as close as it gets, real world environment. So I just wanted to kind of give you a breakdown of where we're about to go today. All right, now here's the bad news. The bad news is our fictitious customer here, let's just say they are a banking organization. They've just been breached. And not by any insignificant actor, they've been breached by the Cobalt group. So this is a pretty high profile threat actor. So know that this isn't going to be commodity malware and just one system got popped. No, we've probably got a pretty nasty spread at this point of this threat actor. So I just pulled a few of the MITRE attack techniques that are known to be leveraged by Cobalt group. For instance, and it's kind of ironic, right? They love to use the Cobalt strike attack tool. So decent chance we're going to see some of that. persistence with run keys, persistence with scheduled tasks. They're definitely leveraging some PowerShell, tools like Mimikatz, and so on and so forth. Process injection, you know, it's kind of the usual suspects here, right? Some unique things, though, that you don't see every day, like binary proxy execution with tools like CMSTP. And honestly, by the way, I just went to, MITRE ATT&CK, researched the Cobalt group, and just extracted all these techniques. So this isn't like tribal knowledge or anything. This is pulled right from well-known open source intel about the Cobalt group. All right, but we don't really know all that yet, right? Because we're just arriving on the scene, okay? The customer called us up and said, hey, I think we've got a security problem. Can you help us out? Okay, Mr. Customer, what do you know so far? Well, one of our users received a suspicious email. This is all we know. The name of the attachment, there you have it. That's it. Okay, Mr. Customer, we'll see what we can do. So let's go ahead and dive into this IR. securityprotocol.doc.zip. Give me a second here, pull up my screen share, and I'll make sure that we get this. Okay, cool. All right. So here we are staring at the Velociraptor server interface. Now, one of the things that naturally has had to take place here is I've packaged up my Velociraptor agent, handed it to the customer, and said, go ahead and use GPO. Deploy this agent across your whole network. That's all I need you to do. All right? So I can quickly check and see, are these systems checking in? So here on the home page of the Velociraptor UI, it's telling me how many connected clients I have up here, somewhere in the ballpark of 60. So I'm going to take a look and see which clients are checking in. I'm going to click up here. I'm going to say Show All. All right. So here's a list of all the systems currently checking into my Velociraptor server. I've got all kinds of systems, right? Looks like SAL for the sales subnet, ENG for the engineering subnet. I've got servers, I've got workstations, got some Linux systems. Cool. Everything's checking in. And I notice over here on the left-hand side, green lights all the way down. I've got active connections. So the Velociraptor agent has a real-time connection to the server at all times. So when I issue commands, they are executed immediately. That's pretty cool stuff. So just to kind of showcase, just intro, some of the cool stuff that I can do with Velociraptor. So let's say, for instance, SAL02 was a system of interest. I just wanted to poke around and try some things. I can click in on this host here. And now I'm looking at that host here in Velociraptor. And one of the quick and easy cool things I can do is, let's say I just want to run some arbitrary commands against it. I can click right here in the top right-hand corner, shell, and I can spawn a shell of any kind here, PowerShell, CMD, Bash even possibly, or run straight VQL, which we'll talk about in a little bit. But let's say, okay, I got an arbitrary PowerShell command I'd love to run, like get process, right? Hit launch. It's going to issue that command down to the endpoint. The endpoint's going to execute the command, and it's going to return that here to me in just a second. Click the window, and there you have it. There's all the running processes on the box. Just a simple demonstration of, hey, run a quick command on the endpoint. What kind of command can I run? Anything, because here's the deal. Velociraptor is running as a service on this endpoint with system privileges. I can do anything that I want to. So running a PowerShell command is just the start of it. All right, so one other cool thing I can do, I love to show this off, is let's say SAL02 was exhibiting, it's got malware on it in some specific location. Sure would be nice to be able to reach into the file system and grab that piece of malware. I can do that. So right up here in the top left-hand corner, the VFS, I can click into that, and I can literally browse the file system of this machine in real time. So I'm just simply clicking through, refreshing the contents of each level as I go. So I'm going to go into the users directory here. And this is happening real time, folks. This is a live system that we're interrogating. So James Green, maybe he's the user on this system. I'll dive into his directory. Maybe he's got some malware sitting in his downloads directory, right? So I'll just go all the way down to that location, take a peek around. Now, naturally, he doesn't actually have malware. But let's pretend this was the malware, desktop.ini. I need to get my hands on that so I can do some reverse engineering. Well, there it is. Collect it from the client. Give it a second or two of round trip time to go and get that file. It's hashed it for me, and now I can simply download it right here to my analyst workstation and analyze that file. Now, because this is actually a text file, I don't even really need to download it. Right here in the Velociraptor UI, I can look at it here in a text viewer. I can look at it in a hex viewer. That's kind of neat. Okay, we're still just talking about the basics here, folks. This is just cool stuff that I kind of like that I can do here. But let's get down to what really matters here. Okay, so back to our incident response now. All right, so what I more than likely want to do at this point is I need to answer the key question. Did this customer experience a breach? Here's the email attachment. All right, the question I want to answer now is who in this environment opened this attachment, right? That's a simple question. Believe it or not, can be kind of hard to answer depending on what kind of tooling you have in your environment. Do you have the ability to interrogate every one of your endpoints for the presence of a file? Sounds simple. It's not. But let me show you how quick and easy that is with a tool like Velociraptor. Okay, so what I'm going to do is I'm going to come over here to the menu and I'm going to go to the Hunt Manager. This is where I can execute a hunt across one, a few, or every single endpoint in this environment. So let's put together a hunt real quick. The hunt I'm going to run is search for suspicious email attachment. We're just going to look for the file anywhere on any of our systems. And I'm going to specify I only want to run this on Windows systems. That's what all my users are using. And the artifact that I'm going to run to look for this is one called Windows Search File Finder. Sorry. And the File Finder artifact is a predefined hunt that allows me to find files, literally, just as simple as that. So we're going to find a file on all of our endpoints. Now, the file that I want to find is based on the name of that suspicious attachment. So here is a search glob that's going to look in every single user's directory on every system in this environment for anything that matches that naming convention of that suspicious attachment here, right? So we're going to go ahead and fire that off and execute. Now, here's the cool thing I like to brag on Velociraptor about. So in the bottom right-hand corner over here where it says total scheduled clients, that's how many endpoints it's about to run this hunt on, and that number will keep climbing to, okay, there we go, 55. Before I was even finished speaking, it's done. It just searched 55 systems for the presence of a file anywhere in any of the user directories. And let's take a look and see what it found. So I'll pop open the notebook here to basically give me a quick summary of the results. So looking at these results, I see I've definitely got this file on probably multiple endpoints. So ACC09, I've got it on ACC01, ACC04. And notice, because I wrote a kind of a wildcard pattern, the original document was securityprotocol.doc.zip. But I hit many different permutations of that, right? I also happen to land on an exe by the same name, by a similar pattern, right? Which, based on the location of this exe, this is what it looks like when you double-click a zip file and execute something from within. So the executable has been unpacked from inside the zip. So not only do I have users that pulled open the zip, but I've got users that maybe extracted out the contents of the zip. And I don't like the look of this executable. Now, let me show you where things get kind of neat with these notebooks. So right now, I'm just looking at basic results of this file finder search, right? These are all the systems that exhibited evidence of this file being present on the machine. So right now, my first determination is, all right, there's your phish victims. These are the ones that at least opened the attachment. They took the bait. So one cool thing I can do to very quickly sort of categorize and classify these machines is I'm going to edit this notebook. And let me make sure you saw what I just did here. Up here, right here in the notebook sort of menu, I'm going to edit this notebook, and I'm going to modify the logic being used here. So the first thing I'm going to do is I'm going to provide more specific criteria for the columns that I want to bring back in this query. Let me zoom in here so you can kind of see what I've got. So I'm simply selecting specific columns, just cleaning up my output, right? Show me the full the FQDN of the host name, the full path to the file, the B time, which is the creation of the file, and I'm just simply permutating that to created time. Cool. Modified time is modified time, and the hash. Now, this is where the magic's about to happen. In the same query, what I'm about to do is, for every system that came back with a hit, I'm going to slap a label on that system in Velociraptor called phish victim, and you'll see the benefit of that in just a minute. So let me go ahead and save this notebook that I've just run. It's going to re-execute the query and then show me these results in just a slightly cleaner output here, right? So there's my FQDN, ACC9, ACC9, ACC1, ACC4. It looks like I got a few more on the next page. ACC5 even, right? Now, let's go back and look at what I just did. So if I come back to my host view, here's all the systems in this environment. Once again, Notice over here on the right-hand side the list of labels, right? So there were already some labels on some of these systems like server, workstation, IT, E&G, whatever. But now I've got several systems in here that have now been assigned the fish victim label, which is going to be very useful to me in future hunts because I can choose to run a hunt on a specific label, right? So if I wanted to dive deeper into only the ones that clicked the link or opened the attachment, now I can be more targeted in my hunts. All right, so let's go deeper. So considering that we're dealing with an APT style actor, right? Not your average script kiddie, and we're coming in well after the fact. So it's safe to say those victims that we have that click the link, and look, I'll just kind of bring them up here in a summary view. Label, fish victim. Let's just look at the fish victims. There they are. There's the 4 systems that are fish victims. I'm going to say it's safe to assume the scope of our breach is probably wider than this. These are the patient zeros. Cool. So how can we quickly identify whether or not our breach is now wider than just these 4 systems? Well, a couple of things that I might do is I'd go find out, well, who are the users of these systems, right? ACC 9, 1, 4, and 5. Let's get those usernames because one of the quickest ways that I can find out has lateral movement taken place is to throw a hunt out for possible lateral movement. So let's say we're going to search for lateral movement of fish victim users. We'll contain that to our Windows systems for now. Select artifacts. Okay, so there's a really cool artifact I can use called Windows Event Logs RDP Auth. Now, yes, it does say RDP in the hunt title, but if you look at the description, it's actually going and getting all sorts of relevant event IDs that would support lateral movement of any kind, not just RDP. So this is a really cool hunt to run when you want to answer the question, has a compromised user moved laterally through my environment? And I already know who these users are, so I can craft my query accordingly. So now that I've chosen this artifact that I want to run, the Windows Event Logs RDP Auth, I've opened the parameters for this artifact so I can provide some additional criteria I want to use in this hunt. So the criteria that I'm going to specify is the list of usernames that I care most about right now. And this is something that I didn't make it extremely obvious. These are the usernames of those 4 compromised systems: Gene Owen, Albert Willoughby, Chad Chan, and Anna Ward. I want to see all event logs related to lateral movement tied to those 4 users. So we'll go ahead and kick off that hunt and see what comes back. Now, while this hunt runs, let me just make a quick point here. One of the downsides of being an IR consultant is that oftentimes I'm dropping into environments, there's no SIEM, there's no log aggregation, there's no Splunk I can just go run a quick query against. So I have to come up with clever ways to do the same thing you would do in a SIEM, but live on the systems in real time. And it's a tricky thing to do, but that's where tools like Velociraptor are going to come in and save the day. So check it out. We're almost done. We've searched almost all of our systems here, 49 of 55. That's a pretty good number. I'll at least go ahead and fire up the notebook and see what we've got. Now, I'm going to have a lot of entries in here, tons and tons and tons. And some of these are going to be really easily explainable. So for instance, we've got Anna Ward here logging onto a system. What system is it? It's the domain controller. That's going to happen, right? Every user in an environment that logs on, the logon events are going to be placed on the domain controller. So that and various other things in this output are pretty safe to at least temporarily filter out if I'm looking for true lateral movement. So what I'm going to do is I'm going to fire up this notebook editor again, and I'm going to paste in a pre-crafted query that I have here that's going to zero in on the things I care most about. And by the way, let me also let you know, all these notebooks that I'm running, I'm capturing off into a GitHub document. At the end of the talk, I'm going to dump a link. You're going to get to go and see all my notebooks that I used for this demo, okay? So don't worry about like quickly jotting down anything that you see here. Okay, so once again, all I'm doing in this notebook is I'm specifying the key columns that I care most about. But what I'm doing now is I'm writing some criteria on filtering specifically for certain users and filtering out their systems. So Chad Chan is the user of ACC01. I don't care about Chad logging on to ACC01. That's normal. But I do care about Chad logging into anything else in this environment except for my domain controller, Exchange server, or file server. Those are the ones that are going to be more, normal, if you will. All right, so there's my notebook. Let's go ahead and rerun that against these results. Whoops, looks like I pasted in a non-printable character. Let me go fix that. And that's just a result of what I'm copying and pasting from, so bear with me here. Okay, so let's see how many results do we have here. 15. This is a more manageable output. So now what I'm looking at are basically logon events across all the systems in my environment by a user who does not use that system. So this is noteworthy to me. Chad Chan uses ACC 01. Why do I see him logging into ACC 05, right? That's that lateral movement we're looking for. ACC 06, ACC 08. Chad Chan's been busy today. He's logging into all sorts of systems in the accounting subnet that he does not regularly use. Furthermore, if you look at the timestamps here, this is rapid, right? He's going from system to system instantly. So this is port scanning maybe, but definitely not regular accountant-like behavior. We've even got our good friend Albert here logging into other systems that are not his as well. So a lot of hits here. Cool. So just kind of demonstrating the capability here of looking for lateral movement very quickly, even though I don't have a seam to run these queries against, right? I can do that here with Velociraptor. All right. Now let's completely throw that out the window, because while that's cool and all that I can look for systems that I suspect our adversaries may have moved laterally to, maybe I don't fully trust that. I'm going to still treat this entire environment as possibly compromised. So let's take some more heuristic approaches. All right, so I've got a hunt now that I'm going to use to baseline all processes running inside this environment. I don't care what system it's on. I want to look at them all, okay? So let's say baseline running processes. That's what we'll do here. Baseline running processes, zero in on our Windows operating systems. Select artifact. The artifact I'm going to run is called PS list. My memory forensics folks will recall that plugin in volatility, similar use case here. So what PS list is going to do is not only is it going to list all the running processes on each system, but it's going to go a little bit further. It's going to hash the executable of that process. It's going to perform authentic code verification. Is this binary signed? Is it signed by a trusted publisher, etc.? And then it's going to return all of that to me in a nice clean table I can do some sorting and filtering against. So let's go ahead and fire this off. We'll run it across the whole environment. Why not? So we'll go back to the overview tab. We can take a look at how many systems it ends up getting dispatched out to, and then we'll watch all the systems reporting in with their results. And of course, I've already got a notebook queued up that we're going to use to sort through all the results that come back. Because as you can imagine, there's going to be a lot of results. There's tons of processes running across this environment. But it's the power of the notebook that allows me to take an overwhelming number of results and whittle it down to the stuff I care most about. All right, Hunt's coming back, so let's get my notebook ready to go. Look at that, it's almost done. I mean, folks, I was confident enough to run all of these hunts right here in front of you because of just how fast this tool is, right? Like, you know, in a matter of less than a minute, right? I'm able to ask this question of 55 systems and get results. Okay, so let's go to the notebook, refresh the notebook here. Tons of results. There's going to be probably thousands of results of running processes on each and every one of the systems, right? So I've got the name of the process, the full path to the executable. I got MD5, SHA-1, 256, authentic code status, right? That it's digitally signed by Microsoft, good to know, and all that kind of good stuff. All right, I'm not about to look through thousands of processes on any of these systems. What I'm going to do is I'm going to paste in a notebook that's going to zero in on things that I care most about. So notice, again, I'm selecting some columns of interest here. Now I've added something. Up here, I've added a function that's going to count the number of occurrences that it finds of each process. And that'll make sense here in just a second. Now the filter criteria, this is what's going to save us, because I'm not looking through thousands of processes. So filter it down to the ones I care most about. For instance, the ones that are untrusted. Authentic code went to check the binary and said, nuh-uh. This thing is not digitally signed, or it's not signed by a trusted publisher. Those are the ones that I'd love to see, because my 508 students will recall very rare occurrence that you're ever going to stumble upon truly digitally signed malware, right? So this is one of the data reduction techniques we can use. Now, I've got a couple of other exclusions in here for known good binaries in this environment, but I didn't have to put many. That's going to help me quiet down the results here. Now, the next thing that I'm going to do that's going to be a force multiplier for me is I'm going to take all these unsigned processes and I'm going to stack them up, group them by their full path to their executables, and then order them by their prevalence. So I'm now looking for untrusted processes, and I'm sorting by how rare they are in this environment. Those are two winning moves here. So let me go ahead and save the notebook, let that refresh my results, and we are literally staring at malware right now. So I've taken all of those results, reduced it down to 8. Now there's a couple of false positives in here, don't get me wrong, but let's look at what we got back. So I've got a couple of process names, securityprotocol.doc.exe. I mean, right away, right? Double file extension, .doc.exe. Furthermore, it matches my first indicator, right? That suspicious attachment. But I got a couple other things in here too. tkg.exe, running out of the root of C users. Not sure what that's about, but it came back in my query because it is an untrusted binary. And fortunately, I've got a SHA-256. So if I really wanted to know what it is, I'm one search away from VirusTotal. But I'm about to show you a trick in just a second that's going to make that unnecessary. Now, a couple other results in here, though, like WinApp Store, Microsoft Photos, Skype Host. OK, false positives, right? Now, I'd have to spend a minute or two making sure, but false positives. But I just asked the question of how many processes are running on 55 systems, and I whittled it down to 8 results with this notebook. And I'm staring at 5 really, really hot entries right here of very likely malware. OK, but let me one-up this one. So what if I told you I could just have Velociraptor reach out and ask VirusTotal for me, are these things malware or not? Give me a second, because my I'm pinwheeling now. I don't know why. OK, there we go. All right, so let me show you a notebook that's going to allow me to do exactly that. Clear this one out, paste this one in. Let me show you what I got here. OK. So this next notebook is very similar to the one I just ran, but I just added a really cool capability. So here I'm specifying an API key for VirusTotal. This is a free one and a throwaway one, so don't try to copy it down. It's useless. But there's an API key for VirusTotal, and I'm doing the same query, right? I'm bringing back all those untrusted processes, right? Grouping them up by EXE and SHA-256 this time. But in my query now, what I'm doing is I'm calling upon another artifact that will do an enrichment of any SHA-256 that I feed to it and go and pull the VirusTotal results of that hash. So let's fire that off and see what we get. OK. Similar results here, right? Got my 4 security protocols and my TKG. What I really care about here is, what does VirusTotal have to say about these guys? Boom, done, right? Definitely malware. We're staring at malware. There it is, right? So I didn't have to open up 4 or 5 browser tabs to go figure this out. Let VirusTotal sort that out for me. Super cool stuff. Now, just food for thought. If you're using a free VirusTotal API key like I am right now, as I mentioned in the comments of this notebook, we're limited to 4 lookups a minute, 500 lookups a day. Use with caution, right? But otherwise, a really powerful capability that we have there. So something that I haven't mentioned is just keep in mind, I'm moving quickly, right? If we were doing a full-blown IR, I'd be extracting things out. I'd be taking notes, copying down paths of malware, IOCs, and all that stuff. But we're moving quick. So one of the things that I would do next is, if I wanted to learn more about these running processes that are definitely malware, I'm going to fire off a quick hunt here real quick that's going to tell me a little bit more about how these processes came to launch. So let's say discover PS tree of known malware. And what I'm going to do is I'm going to choose an artifact called PS tree, which is simply going to interrogate the system based on the regex of certain process names and then bring back to me basically the process ancestry of those processes. So our process regex would simply be this right here, TKG or security protocol with wildcards. I'm going to capture anything that matches that pattern, launch it. Run the hunt, and go. We'll give that a second to come back. And and it is quick. And it's done. So pull up in the notebook, refresh the notebook. All right, this is kind of neat because what I just learned here is, all right, there's your security protocol running on 4 of my systems. How did it come to launch? Well, the parent process is explorer.exe. Well, yeah, I could have predicted that because this was an email attachment. The user clicked it. Got it. But what about this new guy? tkg.exe, right? I didn't necessarily see that anywhere in the context of the email. And furthermore, by looking at the PS tree listing here, I can learn a little bit more about how TKG came to be by studying the process creation ancestry. So it was launched by CMD, which was launched by WIMI Privacy, which was launched by SVC host services, and so on. Possible lateral movement technique, WinRM. This was likely executed on this endpoint. Let's see, what do we got here? What endpoint is this? ITO7. So ITO7 was not one of the fish victims, right? Those 4 ACC boxes were. But somehow ITO7 is running a known malicious binary that got here likely through WinRM, lateral movement. So I bet if I went back to that lateral movement hunt I ran earlier, I'd probably find logons on ITO7 coming from one of my compromised users. But all just to say, look, that's how we can continue scoping this thing. So I'm documenting the names of these executables, the names of these processes, the full path, and so on and so forth as we continue hunting now. All right, but let's switch gears entirely because malware on a system, no big deal, right? Reboot the box, we're good to go. Unless there's persistence, right? So let's go looking for persistence. So back to my hunt screen. Let's find persistence. Run that on my Windows boxes, and I'm going to hit every single one of them. But we're going to be kind of targeted here. I'm going to search for startup items, which is essentially all of the various auto start extensibility points on a Windows system. We're just going to launch it. And that's going to go down to every box, and it's going to look through every single one of the known locations of auto start extensibility points and auto run keys. It's going to pull it all back, and you already know the name of the game, right? I'm going to use a notebook to go and sort, basically show me the least frequently occurring entries across all these systems because that's a really solid way to find evil. Show me the rare entries. So I got a notebook for that. Let me bring that over here. Because I'll just tell you right now, we probably have something in the ballpark of 10,000 entries off of all these machines. Not about to pick through that one by one. All right, so I'll show you that notebook. I know I was kind of moving quickly here. Enhance. Keep in mind that what I'm doing here is I'm sorting and filtering across many, many thousands of rows, so a little bit I/O intensive. So let me show you that notebook that I just quickly executed. So all I'm simply doing is I'm selecting again a couple of key columns that I care about from the auto runs output, and I'm counting based on prevalence, excluding a few of the false positives commonly encountered in my particular environment, and then grouping. So what I'm basically saying here, if I have an auto runs entry with the same name, path, and commands, stack them up because those are obviously the same entry, and then show me only the ones that occur on fewer than 10 systems in my environment. Because that's what? That's about 1/5 of the environment, so that's a pretty generous number to throw out there. So let's see what results it brings back. Let me real quick scroll down to the bottom because I want to see the total count. So we got 20 results here, not a big deal. So if I have to manually look through 20 results, I can do that. So okay, we got some outliers. We got tight VNC on one of our systems. Well, it's an IT system. Maybe that's explainable. I hate that when IT folks put all kinds of cool remote access tools on their systems, but you'll see that. So maybe that's something, but right now I'm going to say maybe not. But this is interesting. So I've got a run key here on ITO7. ITO7 is already on my radar. Got this weird TKG executable running on it. So what's going on in ITO7? Well, I've got this link file sitting in Daniel Bryant's desktop, and it is being launched by a run key. So this is a pretty solid persistence mechanism. Furthermore, this technique right here, super rare. It's an uncommon thing that you're going to see on a healthy system. We could very quickly tie that back to some common TTPs adversaries use. Now this next one gets even more exciting though. We've got yet another run key here, but on ACC09 this time. Now if I look at the launch string of this run key, this one is using a new and less common tool, MSXSL, which is an LOL bin, common built-in binary, that is capable of pulling down XML documents and XSL documents, recompiling them, and building a flat file in the system here. Long story short, this is a super shady technique, but there it is, staring us in the face because of its prevalence. It's only on a single system in this environment, ACC09, right? So that's why it's on my radar right now. Now, a couple other false positives. Somebody's running the Origin client. Anybody know what that is? Origin? No gamers in here? EA Origin? Anyway, so yeah, we've got an IT guy that's got a video game client running on his system. But okay, I'm glossing over a few things here, right? Because this is obviously something that would take some time to sift through these results and make heads or tails of what's normal, what's abnormal, right? But we're moving quick because I got an hour to solve a whole breach right in front of you guys. So bear with me. Okay, another one of those interesting link files being executed directly with CMD. Don't like to see that. So IT01 maybe has persistence. An HTA file. All right, now anyone that's worked IR in the last few years knows HTAs are just rampant. This is a commonly abused file that is essentially an executable, but it's fairly sneaky. It's that HTML application. And what we see here is HTA in the presence of an auto start location here. So this HTA, whatever's contained inside it, is going to execute when Julia logs onto her system. So I'm going to say that's highly suspect. Now, all this stuff over here, don't pay much mind to that. That's basically Velociraptor trying to parse out a binary file, and it doesn't do a very good job of it. So I've actually got a recommendation in with the team to get that output cleaned up. We got an executable here, fd.exe on Julia Jones's system. Once again, ITO3. I'm going to call that suspicious, right? Taking note of each of these possible persistent mechanisms that I'm seeing, because I can't eliminate this adversary if they still have persistent footholds. So Adobe updater.link, not sure what that is, but we might know in a few minutes. But anyway, so several things going on in that output. I need to refresh my window here real quick because I'm getting some connection errors, which might mean my login has expired. Yikes. Technical difficulty, bear with me. Let me log back in here. Okay, we're back. So we did some initial persistent scoping, but that's not entirely thorough because all I was looking at was auto start extensibility points. There are various other types of persistence, like, for instance, scheduled tasks. So let's see if we can find some of those. The demo gods are frowning upon me right now. I was way too cocky thinking I could do an hour-long talk that was a pure demo. Okay, here we go. All right, let's go for scheduled tasks. All right. Windows System Task Scheduler. Just go pull all of those off of every system. You already know the name of the game. Pull them back, sort them by least frequency of occurrence, looking for rare entries on these systems. We'll find a couple of hits, and then we'll move on. So looking at my scheduled task output, let me grab a handy notebook that's going to do some sorting, some filtering, remove some of the common false positives of scheduled tasks, group them, sort them by least prevalence. Let's see what comes back. All right, couple of tasks here. Mishta. All right, Mishta, most commonly associated with execution of HTA files. There you have it. We got another one of those shady-looking HTA files in our environment now, and Mishta is the execution agent for the HTA. All right, ITO2, you're on my crap list. There's that CMTSP. So we talked about this very briefly when I introduced you to the threat actor we were dealing with today, Cobalt Group. This is one of their known techniques. Using CMSTP as a signed binary proxy execution to execute code on a system. So again, if I wasn't super familiar with this technique, wasn't sure what it was, it's on my radar right now because it's only on a single system in my entire environment. So I'm going to dive deeper and figure out what's going on there. So it's a scheduled task called temp. All right, now we've got some hide my ass VPN stuff. All right, this is somebody with some PUA on their system, right? Yes, it's rare, but this is probably not our adversary. I got a PowerShell process here running some backup script. I might have to reach out to the IT team. Hey, whoever's using IT13, what's this about? Okay, that's normal. This is a backup script that he runs. Okay, cool. I'm learning more things. I'm learning more things. All right, now anyone that's taken 508 or has been doing IR for a while knows, why is he doing all this manual stuff looking for persistence? Why don't we just run auto runs on these systems and see what comes back, right? I can do that. So autoruns is a third-party executable from sysinternals that does a phenomenal job at pulling out all the most popular persistence mechanisms off of an endpoint in one swoop. But it is a standalone binary. So in theory, I'd have to push that binary to all my endpoints, execute it, and then retrieve the CSV. There's already a Velociraptor artifact for that. So let's go ahead and go run that bad boy just to see what comes back. Auto runs. So I'm going to use a custom one, but there's a built-in one here as well. So this is out-of-the-box capability of Velociraptor. So I'm going to go ahead and kick this off, let that push down to every single one of my systems, execute, bring back results. But while it does, we'll continue pressing on here. All right, so I'm going to start queuing up another hunt real quick, because at this point, I have already learned about several potential malware locations on various systems, right? So I've taken note of MSXSL, any kind of HTA file. Here in just a minute, we're going to learn about another suspicious binary on one of our boxes, TKG, security protocol, and even that really strangely named TXT file that was being executed by our signed binary proxy execution tool. So while this hunt's running, let's kick off another hunt, because one of the key questions I want to ask right now is find all systems with known malware. I've already got the names of this malware, so it should be relatively easy to say, show me every system in this environment with hits on this particular malware, using, once again, our file finder artifact, right? The file finder just simply says, give me a search pattern of a particular file, and I will go and retrieve it anywhere on any system that it's on. Now, in the essence of time, I just created a custom one that's preloaded with the files I want to find. So here it is. If I go to configure parameters, you can see exactly what this would look like. I'd come in here and say, I want to see anywhere on the disk that MSXSL is, or any HTA file, because these are actually pretty rare, HTAs are. There's also an SVC host executable that we're about to learn about in auto runs, another persistence mechanism, sitting in C Windows System 32 drivers, which is not the proper home for SVC host. But we saw TKG, we saw security protocol, and we saw this really shady looking TXT file. But you know what? I'm not convinced. I want to know for sure every system that contains any one of these file patterns. So let's kick that off. While that's running, we'll go and check on our auto runs, and it's nearly done. All right, let's go look at the output from auto runs, and you know the name of the game, right? Sorting, filtering, grouping. Let's look for least prevalence of our auto runs output. So real quick, there's the notebooks I'm looking for here. I'm looking for things that are not digitally signed, looking for things that are enabled, and I'm grouping them up by image path and launch string, and then just show me the results that show up on fewer than 5 of my systems, leveraging least frequency of occurrence to quickly bring the interesting entries up to the top. Now this might seem a bit redundant, right? We've already looked at scheduled tasks. We've already looked at auto runs locations, but I'll just go ahead and tell you, auto run C is better. It's more comprehensive, and so that's why I'm kind of showing you the evolution here. So bringing back the results from auto run C. Some of these things we've seen before, right? We see our execution of HTA files. We see some of these suspicious link files that are being executed by CMD. So there's a few other entries in here. The one entry, though, that we have yet to see, at least in detail, is Adobe Updater here. So this Adobe Updater link file, what was not immediately obvious to us before is this link file calls on a very shady SVC host. Why is this shady? That's not where SVC host belongs, right? Now, I'm calling upon some knowledge here, right? I've got to know what normal looks like on a Windows system. SVC host is a normal binary, but it does not live in C Windows System 32 drivers, so that's what's caught my attention here. And furthermore, if that is truly a system binary that's being run by a legit task, why is it only on one of my systems? All right, so that's now on my radar as well. So I just wanted to circle back to that so that it made sense to you why the files I'm hunting for include SVC host sitting in that drivers directory. All right, so let's look at our results from the file finder, looking for all the locations across this whole environment for these known bad things. So I got some results here, but I'm going to clean them up really quick with a notebook. So I'm just simply choosing which columns I want. To quiet down the output here, make these results a little easier to see. Okay, so now I see which system did it have a hit on, what did it find. So there's all your security protocols, there's your security protocol exe. Hey, there's an MSXSL I didn't even know about yet. I knew about this one. I did not yet know about this one, but my search glob found it. There's an HTA file. There's another security protocol. Let's expand. I got more results. Another HTA file. There's good TKG on 2 different systems in 2 different locations, but I found them either way because of the regex pattern that I passed to the file finder. So I've got many systems now in this environment with positive hits for known bad stuff. And it was really quick for me to find these, right? So now what can I do with these? So if these systems have positively confirmed malware on them, one of the first things I might want to do is let's slap labels on every one of these systems. These are compromised. These systems are compromised. And I'm going to do that with a slightly modified version of my notebook here. So all I did was I just added a slight tweak to this notebook where it's going to take every one of those systems and assign the label of compromised because it's got known malware on it. So let me just rerun the notebook. Now all those systems have been labeled compromised. Real quick, let me just show you what this looks like. Go back up here, label. Show me all the systems I just slapped the compromised label on. There's more than a couple, right? Now, what's interesting about that is, look at the ones that were phish victims. 1, 2, 3, 4. Notice the scope of my intrusion is a little bigger than that. I've got IOCs on many more systems than just the phish victims, which in an APT-style breach is oftentimes the case. All right. Let me show you guys some magic now. So, all right, we get it. We can do the scoping. We can look for IOCs, persistence mechanisms, and all that jazz. Look, we know this adversary is known to use Cobalt Strike. Can't we just look for that real quick? Yes, we can. Let me show you an easy button real fast. So if I wanted to look for Cobalt Strike in an environment, right? One of the quickest and easiest ways I can do that is Yara scan all processes for Cobalt Strike. So kick this off against all my systems here. Throw in a quick search for Yara. You're going to see there's a variety of different Yara artifacts. I can Yara scan the file system. I can Yara scan memory. So let's scan memory for evidence of Cobalt Strike. So if I click on the parameters for the Windows Detection Yara process artifact, it will allow me to, first of all, I could be very specific about, well, which processes do you want to scan? Scan them all. Why not? Oh, and by the way, if you find hits, go ahead and upload those processes so I can do some REs, static analysis, what have you. Now, this is cool because say I have a particular Yara signature that I want to run, but it's hosted on GitHub. No big deal. Go grab the URL for the raw version of that Yara rule, paste it right here, and that's the one it's going to use. But what if I just wanted to find Cobalt Strike? There it is. It's built in. This is a Cobalt Strike detection rule. It's the default rule. If you don't pick a rule, it's going to use Cobalt Strike automatically. How convenient. Okay, so I can choose a whitelist if I need to, but I don't. So let's just launch this thing. All right, so I'm about to issue a Yara hunt against the memory of 60 systems to just simply tell me, is Cobalt Strike anywhere in this environment? I don't know. I think that's kind of cool. So 55 systems, 6 are done. Give it a little bit of time here. They'll start rolling in pretty quickly. I say that, but it's also happy hour, so we'll see how quickly these systems are moving. No. So the question is Cobalt Strike the only attack tool that I could run a Yara scan for? Not at all. Any Yara scan you can imagine. Meterpreter, Empire, double pulsar. There are Yara signatures for everything out there, right? So whatever it is I'm suspecting that I'm looking for, I would just go find a good Yara signature for it and feed that right to this artifact, and then boom, go hunt for that. You bet. I could also have a compiled rule set of Yara signatures so that basically, even if I have no idea what I'm hunting for, here's an entire collection of Yara signatures. Use them all. Now, being mindful of resource intensive, right? That's going to be a little intensive to search an entire file system or all the processes for 1,500 Yara rules. So being targeted, it just helps us save time. And if I already have intel about what this threat actor leverages, Cobalt Strike, there's the rule I'm going to start with at least. Okay, so the results are pouring in, not as quick as some of the other hunts, right? Because some of these systems have several many gigs of memory and lots of processes running. But as the results are pouring in, let's just go see if we can get a sneak peek here. Well, that didn't take long. We've definitely got some hits. Now I'm going to clean up this output real quick, as you know I like to do, because sometimes these results come back and it's like there's a lot to see here. What's really important? So I'm going to just filter and clear out some of these columns. Show me the host name of the system, the process name you found a hit on, the process ID, and the rule that you hit on. Let me just refresh. All right, that's a little cleaner, a little easier to see. So what it is telling me is we've got Cobalt Strike on ACC 9, ACC 5, ACC 3, IT07, ACC 01, and ACC 04. And a couple of these I could have seen coming, right? Security protocol, got it. TKG, yep, got it. But that guy, that's a little scary. And if we did a little bit more, searching, what we'd find is that is actually the legitimate services.exe. It's not like masquerade or hiding in another location. That's it. That's the legitimate services.exe. But what's happened here is our adversary has injected into that legitimate services.exe. We found it only because there was a direct match for Cobalt Strike Beacon inside that process. So we've got an injected process. That's tricky stuff because I can't just terminate that process. Yeah, I could kill TKG, I could kill security protocol, I can't kill services. So we got to get a little bit more precise, a little more surgical when we get to our eradication phase, but I'm just calling that out. Now, here's the deal. Cobalt Strike is on these systems, right? It doesn't get much more compromised than that. So once again, what do I like to do? Let's slap a label on these guys and just simply say, hey, for any system that came back with a hit, go ahead and label it. We got Cobalt Strike on that box. So save it, rerun it. Now the label's been applied. So if I come back up here and say, first of all, show me all those compromised boxes. There's all my compromised systems. But now look, a couple of these systems came back with Cobalt Strike. A couple of them did not, right? But these labels are going to be really useful to me here in about a second. So here we are. We are staring at a dumpster fire in this network, right? We've got a lot of systems with malware on them. We've got a handful of systems with active Cobalt Strike beacons running on them. I mean, this is kind of a worst case scenario for this environment. So again, we're not diving into deep forensics at this point. I'm in disaster recovery mode. I need to stop the bleeding. I need to prevent additional spread and additional damage. And I at least now know fairly confidently this is where the threat actor is in this environment. So one of the next things I'd probably do is let's quarantine every one of these boxes that's got bad stuff going on it. And I can do that very easily, and I'll show you how. So I can run a hunt, quarantine all compromised systems. And the way that I'm going to target that hunt is by the label that I've assigned to those systems, compromised. Every system with a compromised label, we're about to quarantine. What artifact? Well, naturally, the quarantine artifact. So what this artifact's going to do, and it's brilliant, it's going to push down firewall rules into the Windows firewall to block all network communication except back to Velociraptor. So I don't lose access to the box, but the box can no longer talk to anything else but me. So I can keep doing my hunts. I can pull forensic data. I can do whatever I want, but that box is now harmless as far as the network communication goes. So I could kick off that hunt and boom, in one fell swoop, just quarantined every single one of those systems. Now I'm not gonna execute the hunt because I'm gonna show you a couple more things, at least one more thing here. So naturally, at this stage in the incident response, I have at least stopped the bleeding. The affected systems, the impacted systems, can no longer do any additional damage to this environment. Now, this is only where the forensics begins, right? That's a whole nother conversation, which is why 508's a 6-day course. But at least the bleeding has stopped. Those systems are now quarantined and they're not doing any additional harm. But naturally, for those of you that are on the forensic side of the house, one thing I'd certainly want to do before I just obliterate these machines is I need to do a deeper dive, or at least prepare for a deeper dive from a forensics perspective. So one of the awesome things that I could do with Velociraptor is I could perform triage forensics acquisitions from every one of these systems with a single hunt, and I'll show you how that would go. So let's say pull triage acquisitions from compromised systems. We're only going to run that on those with the compromised label because I'm about to upload many, many, many gigs of data, so let's be targeted here. So the artifact I'm going to use is one that might be familiar to some, CAPE files. So CAPE is an awesome triage acquisition tool written by Eric Zimmerman, okay? We're not going to use CAPE per se, but we are about to use the open source CAPE files, which is simply just a collection of well-known evidence locations that you care to get in a triage situation. We're going to get event logs, prefetch files, registry hives, you name it, all of it. And that's all thanks to this really awesome collection of known good evidence locations here in the CAPE files. So when I go to the parameters here, it's going to ask me, what evidence would you like to get today? Well, a really solid choice, if you don't know any better, is the SANS triage collection, because this is basically a grouping of all of the most valuable artifacts decided upon by Mark Hallman on the D for forensics team. Basically, pretty much everything you'd probably care to get, right? We're going to get MFT, USN Journal, you name it. The list goes on, right? So I'm going to click SANS triage, and then I'm going to kick off a hunt. And what that's about to do, it is going to reach into every one of these systems, and it's going to pull about 4 to 6 gigs, maybe, give or take, of evidence off of each one of these boxes before we blow it away and re-image them, because we all know this is where the deeper dive forensics needs to go now, right? Because I still have some questions we're going to have to answer for the customer. I can say, hey, look, I've stopped the bleeding, but you still need to know, has financial data been impacted, or has customer data been impacted? Did they make off with the plans to the Death Star, whatever? And that takes deeper dive forensics, right? So I just want to make sure that I'm differentiating here. Everything I just showed you was like break fix, emergency IR, right? Quick scoping, find the malware, find the persistence, quarantine the systems, the damage is stopped. This is where the forensics begins, and that's a whole nother conversation. One last thing I want to show you, just because it's too cool not to show you this. So one of my 508 students introduced something to me this week that I'm still like just giddy with excitement about. So let me pull it up here real quick. He showed me a tool called Hayabusa. And for those of you that are familiar with a tool called Chainsaw, it's very similar. I'll explain what Hayabusa does. So Hayabusa will basically analyze, let me find a good screenshot here. It will analyze an entire folder full of event logs, and it will very quickly search those event logs for about 1,500 known threats based on Sigma rules from the Sigma project, as well as several built-in rules that Hayabusa already has that says, hey, this is known bad, this is evil stuff. I guess these screenshots don't really do it justice. But OK, here's a good example of one. So for instance, this is a screenshot of the logs generated by, I'm sorry, not the logs, but the CSV generated by Hayabusa. Let me just get this in a better, come on, there you go. OK, so if I ran Hayabusa against a system, it's going to go through all the event logs, and it's basically like having a seam without having a seam, right? Because it's going to go through all the event logs, and it's going to look for threats, find all the threats. So imagine the value of a tool like this. For an IR consultant dropping in a new environment, there is no seam. There is no log aggregation. So I have no quick way to go and say, show me everywhere in this environment that Mimikatz is executed or Cobalt Strike's been installed or what have you. Hayabusa can do this. But here's the thing. It would require me to walk up to that system and run Hayabusa against those EVTX files, generate the CSV, walk away with it, and analyze it. Anytime I discover a tool like this, the first thing that comes to mind is, I got to Velociraptor this thing. And we have. And I'll show it to you. So I was a little short on time this week because I had to teach this SANS class. And so I didn't have the opportunity to write the artifact myself, but I kicked it off to one of my really, really smart colleagues, Whitney Champion. And she took that Hayabusa tool and she created an artifact out of it. So we're going to be pushing this back to the Velociraptor project here really soon. But essentially what I was just able to do with this artifact is reach into 55 systems, search through all the event logs of those systems, apply about 1,600, 1,700 threat rules to those logs, just bring me back the threats. Show me every bad thing that you found. I basically just deployed a seam after the fact. Where there was no seam, suddenly there is. So all I'd have to do is come through with the notebook. You already know my approach here. And just do some simple things like, hey, let's sort for, show me all the critical detections, right? So there are some critical detections. We got base 64 encoded PowerShell. We've got NTLM downgrade attacks where some of that lateral movement had taken place. And the list goes on. I hate to tell you this, but there's like, I think the CSV of detections in this environment was like 32,000 rows. It was a lot. So I haven't done much sorting and filtering against this notebook. All I can tell you is it found just about everything that this actor did. And that's just incredible. So that was kind of just my last minute kind of bonus add-on. We literally finished this artifact this morning. So it was like, sweet, just in time for my demo. Because again, you know, it's a force multiplier when I can have seam-like capabilities in an environment where there certainly was no seam. Okay, well, I think we got it done in just under an hour. Anybody got questions? Go ahead, yeah.
Thinking long-term past forensics, does Velociraptor help organize timelines for after-action reports?
So the question is, does Velociraptor help organize timelines for after-action reports? Velociraptor can generate timelines. Absolutely can. So one of the cool things about Velociraptor, it's not just a simple, hey, go fetch this stuff for me tool. It can actually do the processing as well on the endpoint. So for instance, common piece of evidence we like to get for forensics, prefetch files, okay? Well, I can simply retrieve the prefetch files. Yeah, that's fine. But now I got to process them. I got to parse them. No. I'll just have Velociraptor do the processing and just give me the timeline. And there's many timeline-related artifacts built into Velociraptor. It can timeline the history of an entire Windows system on its own. So I can outsource that CPU labor to the endpoint itself. Timeline yourself and just give me the CSV. So yes, it can do that. But then it's going to be kind of up to the analyst to decide what components of that timeline belong in a final report, right? So unfortunately, there's still not an easy button that will just, boom, produce my executive summary, right? So that's still on you and I to write. But yeah, it can do some really awesome timelining things. I saw a hand go up. Go ahead.
Does it have any app integrations? I know specifically it adds whether that can be used for like an existing inventory system.
That's a really cool question. So she's asking, does it have any integration with, for instance, inventory systems? Because here I can assign these labels, classifying different systems as critical systems, domain controllers, web servers. So I won't say it has any built-in integrations, but we personally have written our own integration for our own inventory system so that I can log into our inventory system and assign a label to one of those systems as critical, web server, whatever, and then it's going to synchronize with Velociraptor. So it's an open source project, right? So most of the time when you're looking for a really cool integration with another tool, it might exist, but the chances are it's on you and I to figure it out and build it, right? But I can tell you it has been done. There is an API to Velociraptor, so anything you can imagine can be done. You just might have to DIY it. So there's that. Let's see here. Let me get my slides back up. Okay. Well, then let me send you off with something here really quick. I have a bit.ly link up here. If you want to take a look at all of those notebooks, because I know I was moving quick, right? If you want to be able to go back through and see all those notebooks that I wrote to do a really quick assessment of some of those hunts, I've got every single one of them captured here in this gist, and you can pull that up. Another thing that you'll have in that gist, if you're interested, are read-only creds to that Velociraptor server I was just on. I'm giving you all the ability to log into that server and poke around. You're not going to be able to run any hunts or do anything, shady because, let's be honest, we're all security people here, and, security people have the best sense of humor. So it's read-only, but it will allow you to go and look through each of those hunts that I just ran, go through the results yourself. check out the notebook, mess with it, right? And I'll tell you what I'll do is that I'll leave this environment up for about another 24 hours. So about till maybe this time tomorrow night. Feel free, take time. If you want to log in and check it out, by all means, go ahead. Also, just closing out, if anybody would like to follow me on Twitter, like to tweet about cool things sometimes, that's my handle. And definitely please check out my company, Recon InfoSec. We do a lot of really cool stuff from CTFs to managed detection response, instant response, and all that good stuff. Otherwise, thanks so much for spending Thursday evening with me. If anybody wants to hang out and chat, happy to do it. Otherwise, enjoy your night. Thanks, folks.